Alright, to finish off Objective 2, operations on functions, I'm going to model how I would work with a subtraction problem. Now, the other operation is addition, but addition is very similar to subtraction. So, again, I'm going to take it step by step, so please write down the steps exactly how I do them. And the steps are again written up here in red. The first one, if I was given number 8, and again it says perform the given operation, I see that it says find h of a minus g of a. So I know that I'm working with subtraction from right here. So the first step again is very important to set up the problem exactly how I want to do the math. So rewrite the functions, put them in parentheses with given operation in between the two. So my first step, I'm going to rewrite. It says find h of a, so I know I put h of a first. So a cubed plus 2. Then minus, in this case I do have to put the operation between the two sets of parentheses, g of a. And g of a is, parenthesis, negative a minus 4. So I'm done with step 1. Step 2 then says to perform the given operation, reading left to right. And in this case with subtraction or addition, I start to hunt for like terms within step 2. Multiplication didn't necessarily matter right away, but this time it does. And reading left to right, the leftmost term is a cubed. And like terms exist between the two binomials. So I need to look to see if there's any like terms with, or a cubed has any like terms within the second binomial. Alright, so a cubed in the second binomial is over here, negative a minus 4. There are no like terms. There are no other a cubes in the second binomial. So I know that there's no math to be done with a cubed, so I can just bring it down for the ride. I didn't do anything with it. But that also means that I'm done with the cubes, a cubed, so I can cross it out so I don't get confused. Then again, left to right like a book, I look and see the second term of the first binomial is 2. And I look to the second binomial to see if 2 has a like term. And in this case, it does. It's negative 4. 2 and negative 4 are both numbers or coefficients. So now I actually have to perform some math. So I'm going to write 2, reading left to right, 2, and then I have minus, so I write minus, a negative 4. And it's very important, this is why it's so important to show your work, because working with minus and negatives and just positive and negatives in general, you can do a lot of simple math errors. And I don't want you to have to do all this work and get something wrong because of a simple math error. So please write out your work exactly like you're doing it. So 2, again, 2 minus a negative 4 equals, and we can do this math, 2 minus a negative 4 minus a negative becomes positive. So 2 plus 4 is 6. And I am done with the 2, and I'm also done with the 4 because I used the 4 in that operation. So finally that leaves me with this negative a. Now there is something important here. This negative a exists in the second binomial, meaning it's being subtracted from the first binomial. And if you notice, there's no more terms left in the first binomial. I've used them all. So negative a doesn't have a like term. So I'm going to bring it down here. But because it's in the second binomial, I still have to have this minus sign act upon it because it's still part of the binomial that's being subtracted from the first binomial. So this minus sign still acts upon that negative a, so I have to put the minus sign down here in my work that I'm going to show. So in this case, and this is very important because it's going to actually switch the signs of the a. Again, minus a negative becomes positive, so I'm left with a positive a. That's why it's really, again, very important to show your work. If this negative a existed in the first binomial, it wouldn't matter because it wouldn't be part of the binomial that's being subtracted from something. But because it's the second binomial, I always have to look at that operation that's existing. And because it's subtraction, I have to do the math because the signs change. So at this point, I am done with step 2. I read it from left to right. I combined like terms, if there were any. In this case, we had some. And now, I combined step 2 and step 3 with subtraction and addition. So I can jump to step 4, which is writing it in standard form. Highest power to lowest power. In this case, the highest power is a cubed. Then, I don't have any a squareds in this case. So the next highest power after a cubed will be a to the 1. So I write plus a. You can write a to the 1, you don't have to, I can just put plus a. And then finally, I have a positive 6 left over as well, so I have plus 6. And I am done. Please square and check your answer. Now, at this point, please pause your video and try number 9 on your own, following it step by step, just like I showed you how to do. At this point, you should have paused your video and tried number 9 on your own. And I'll take you through step by step my thought process, so please be following along and checking your work with mine. First step, I rewrote the problem and I put each function inside of a parenthesis to become a binomial. G of x minus f of x, I get x squared minus 2x, that binomial subtracting the binomial of 3x minus 1. Alright, then step 2 is I actually start to look for like terms and perform the subtraction operation. And I read it left to right. My first term left to right is x squared, which I have underlined here. I look for a like term in the second binomial over here. X squared does not have a like term in the second binomial, so there is no operation or no combining necessary to be done for this term, so I just bring it down and along for the ride, which I've done right there. Moving on to the next leftmost term, which is negative 2x. Again, looking at the second binomial to see if there's any like terms. In this case, there is a like term of 3x. And I've showed this work here. Negative 2x minus 3x is a negative 5x. So those two terms combine to become negative 5x, and you see that in my final answer. And then finally, and again, I can be, as I'm going along, I can be crossing out the ones I've already worked with. I've done the x squared, I worked with the negative 2x and the 3x. Now finally, all I have left is this negative 1. And hopefully you notice that that negative 1 exists in the second binomial. So this subtraction sign has to operate onto the negative 1. So that's what I showed right here. I have minus a negative 1. Minus a negative 1. And you have to do that because it's in the second binomial. So in this case then, minus a negative becomes positive. What was a negative 1 becomes a positive 1. And it shows up in my answer. So my final answer is x squared minus 5x plus 1. If you don't have that same answer as I do, please raise your hand or check with a neighbor and see if they can help you through it, or please raise your hand so I can come by and check your work as well. At this point, you're ready to practice. I've given you 4 problems, sum, multiplication, addition, and subtraction. Your goal should be mastery 4 out of 4.